1, then we can add a new matrix like this. And the rest we have assigned to zeros automatically, so we can expand it easily by a command like this. If the subscript is outside the region, we can use it in that way. And also there are two useful commands to extract the dimensions of a matrix. One is size A. There is no return variable, so the result will return to ANS directly. And we have a column. We have a vector here. 5 for the number of rows and 6 for the number of columns. And this command can also be called in the other way. So we can get the number of rows set to n and number of columns set to m directly. And this command will return 2 results. So that's enough for a real matrix. What should we do with a complex matrix? In C, you have to create 2 matrices. And it will be quite difficult to combine them together. However, in Matlab, the command is quite simple. 1 times j9, we can use 1 plus 9 I or j should be the same. We do not have to use the star there. And this is shorthand notation for 9j. So we can easily express the first row, and then the second row, and the third row. Easily we follow the same structure, same kind of command structure. You can express a complex matrix. So there's not enough space to display them, so it is displayed in 2 parts. And now, how we can find the determinant of it? As before, we use a command like this, and we should get it directly. We do not have to use the separate command. We can use the same command and get the result directly. And also for C equals to INVB, and it can be used to get the inverse matrix directly. Okay. So this command can be used both for complex matrices and for real matrices. You do not have to distinguish them. It can be done automatically. And there is a special notice here. For the first command, you have to be very careful sometimes. You cannot write it in this way. There shouldn't leave there a space. If you leave a space there, Matlab will interpret it like this. This is the one term, this is the other term, this is the other term, and this is the other term. So we have 4 terms in the first row. There should be error more consistent with other rows. So you should be very careful not to leave a space there. And also, in the command, we can use the star mark there for multiplication of I and 1. We can do that. However, you must be very careful because I sometimes may be used for other purposes. For instance, if you are using a loop, you're sometimes likely to have 4i equals something. Then I is redefined, so you should be very careful with it. If you want to use it in that way, you have to give this command first. I is sqrt -1. it. Otherwise, if you use the command like this, if you are using the star multiplication like this, there might be errors. So the best way is to use the shorthand notation like this. And I have explained the first kind of statement, the direct assignment statement, where you have left-hand side as a variable name and then equal sign and then expression. So you can calculate the expression and then assign the value back to the variable. And this is one way to use Matlab statement. The other way is function call. The function is usually defined like this. I shall explain more about this later. The function is defined like this. You have several input variables, and then after the function call, several variables will be returned. So the function can be considered as a information processing unit. You get some input, and then after processing the information, you get the output. The function is something like this. So if you explain this to you later. And in the function call, it can return several variables at the same time. For instance, I've used the size command. Two variables are returned. One is the columns of A, and one rows of A and columns of A. And this is one way to code the command. And we have other ways to code the command. Something like this, n equals size of A, where you have a vector n return contains the rows and columns of A. So a function can be called in different ways. I shall explain it how to realize it later on. A function of Matlab often corresponds to a .m function, a .m file in the Matlab directory. Sometimes the function could be a built-in function. In that case, the .m file does not exist. Apart from the standard functions, we can sometimes have anonymous functions and inline functions. We will explain later on. And also overloaded functions. If you define an object, you can write your overloaded functions to perform different kind of tasks.